All right, ladies and gentlemen, hope you're having a great day working with trig graphs. Now we are going to focus in on two specific trig graphs. And it's kind of the two that stand alone. If you were to look at all six of them, you should notice that two are pretty different than the other four. And I would love to be there to see what your guesses are, but hopefully you would see that all tangent, cotangent, secant, cosecant all have asymptotes. They're not a continuous function. They all have these gaps and breaks in them because of regions that are undefined. But sine and cosine are these nice, simple wave functions. And so those two kind of stand apart. And there's some things that we can talk about sine and cosine that we can't talk about in the same way of those other four functions. And so what we're going to do today is we're going to focus in on those two functions, and we're going to change the equations a little bit. I'm going to give you some clues at how that will change the graph of the function as a whole. Okay? But the one thing I want to do is I want to make sure that you're pretty good at just graphing a sine and cosine function. Like if I said, okay, graph y equals sine x, all right? I'm going to show you exactly what I think of when I think of graphing y equals sine x. Even if I have to do it by hand with nothing fancy. If I say y equals sine x, first of all, I know that that starts at the origin, okay? And then I know that after an entire cycle or entire period, it ends at the axis, okay? Halfway in between those two, it also passes through the axis. Halfway between those first two, it hits its high point, and halfway between the latter two, it hits its low point. And so the function looks something like this, okay? And I know that right here is at positive 1, and down here is at negative 1. And so right here, I can kind of pretty simply illustrate what y equals sine x looks like. I'm not saying that every single point on here is perfect, but I'm saying that that's a pretty good representation of y equals sine x. Now, if yours looks like this and is very sharp, that's clearly not very good. You don't want it to come up like this and then come down like this and come up like this, because that's not what it does either. And so we want to be a little bit careful, but it should be, generally speaking, you should be able to draw it like this. Now, if I'm doing y equals cosine x, okay, y equals cosine x. Again, I'm just going to draw the axes, okay? And for this one, I know that it starts up above the origin. And also, after an entire cycle or entire period, it ends up above the origin. And halfway between those two, it hits its low point. And halfway between these first two, it passes through the x-axis. And halfway between these latter two, it passes through the x-axis. So I graph those 5 points and then say, okay, it looks something like this. It comes down, hits that, and goes up. That's pretty rough looking. Let me see if I can fix that back part. There you go, a little bit better. Okay, and I would say that's a decent representation of y equals cosine x. And so and again, this part right here is at 1, this part right down here is at negative 1, and you should be able to, and I didn't mark this earlier, this is 2 pi. And I should be able to go, okay, so therefore this is pi, because that's halfway between, this part right here would be pi over 2, because that's halfway between 0 and pi. This part right here would be 3 pi over 2, okay? And these would be the same. And you should be able to graph that much. Okay, this is a graph that you should be able to draw, and you should be able to come up with these coordinates and these different tick marks and be able to understand how to break this up. All right. If right now, if that's something you need to do, everyone in here should go ahead and practice. I forget about if you need to. I want everyone in here to go ahead and practice drawing these one time, and let's see how well you do. Okay? Try to do it the same way I did it and see what you get. We can pause the video right here for just a couple minutes till everybody can draw y equals sine x and y equals cosine x. All right, hopefully your drawings look about like mine, and hopefully with a little bit of practice, they might begin to look a little bit better than mine, okay? So now what we're gonna do is we're gonna talk about how to transform these sine and cosine graphs, okay? The first thing we're gonna take a look at is amplitude, all right? Amplitude, we kind of defined amplitude as the height of a wave or the depth of a wave. And with the y equals sine x function, the height is 1 and the depth is 1. And even if we're looking at cosine, the height is 1 and again, the depth is 1. I don't talk about the depth being -1 because the depth is a length, and so the depth is 1. All right. And so the amplitude of these functions as they are is 1. And so what we can do is if we slip a number into that function, it will change the amplitude. And here's where we have to put it. If you put any constant in front of those functions, that will change the amplitude. Okay? You can see I have here y equals a sine x and y equals a cosine x. And the absolute value of a is the amplitude, not a itself, because a could be negative. You could put a negative number in front of the function, but the amplitude is a length, and so that is always going to be positive. So even if that number is negative, the absolute value of a is the amplitude. And what I want to do is I want to try to go, okay, let's see if we can graph some of these, all right? And so I've got one right here. And I am going to show you how I'm going to do this one. And then I'm going to have you guys try the next two. Okay, so I see y equals 3 sine x. I know that this is the a value right here. So therefore, the absolute value of 3 is 3. So the amplitude is 3. Now, I'm not going to graph this radically different. I'm still going to say, well, I know it starts at the origin. I know it ends by passing through the axes. And so this is 2 pi. I know that the halfway point between these two, it passes through the axis, and so that's pi. I know that right here at this point, it hits its high point, and I'm going to put that high point maybe up here. Maybe I'll go, it might be a little bit hard. Well, I'll put up one higher, right here. Okay, and then I know it hits its low point in between these two. Let's see here. And so this number right here, this is pi over 2. It hits its low point in between these two, and this is 3 pi over 2. And so we go 1, 2, 3. Okay, and that's going to be down there. Okay? And so if I say this is 1, this is 2, this is 3. Same thing here, -1, -2, -3. Then the graph would look something like this. It would go up to this one, down through here. Oof, got a little rough right there, didn't it? Okay, let's try that one again. I can do a little bit better. Okay, goes up through this one, down through this one. Oh, even worse. Last time. And we'll just live with it no matter what. Yeah, pretty bad. But we're going to call it, okay? And so there is y equals 3 sine x. And I can see clearly that the amplitude is 3. Okay? And so that's generally how I'm going to graph these. What I expect from you is some of the things that I've drawn on here. What I want from you is you should have labeled the axis so that I can see what the amplitude is. Also, you should label the x-axis so it's clear what the period is. All right? So now what I'm going to do is I'm going to put 2 of them on the board, and I want you to try to do the same thing. I've got y equals 4 times cosine x, and y equals -5 sine x. All right? We can pause the video right here, and for a couple minutes, you guys try these two. All right, let's see how you did, okay? So y equals 4 cosine x. If you remember, we're going to go back up to the cosine function. Remember, that always started up above the origin, and it ended up above the axis, okay? So this one's going to be the same way. Now it says y equals 4 cosine x. And so if that's the case, then this thing is going to start 4 units up above the origin. So I'm going to say 1, 2, 3, 4. Okay, and I'm going to go down 1, 2, 3, 4, because I know the low point is going to hit -4. I know it starts up above the origin. It ends up above the axis as well. And so I'm going to say, hey, this point right here is 2 pi. Halfway between there, which is about here, I'm going to say that's pi, and that's where it hits its low point. Halfway between those first two, this must be pi over 2. Halfway between the second two, that's 3 pi over 2. And it passes through right here, right here. And so if I was going to graph that, it would look something like this. Something like that. That's not perfect, but you can see I've got the basics. If anybody was to look at this graph, they could tell because of what they see here and what they see here that the amplitude is 4. And they could tell that because they're seeing one complete cycle or one complete period of the whole thing and it ended at 2 pi, they would know the period is 2 pi. All right? Now, this last one, a little bit tricky. I'm sorry, this was kind of a curveball, and maybe you didn't know how to do this one, and I'm sorry. But it says y equals -5. And I'm curious if anybody really kind of put a little bit of thought into what would that negative do to it? And so let's kind of think about just linear functions. If I had y equals 5x, that would be an incredibly steep linear function. Looks something like that, okay? But if I had y equals negative 5x, that would be, again, a very steep linear function, but the one difference is that it would be going down, but not going up. It would have a negative slope. And really, that's the same kind of thing that happens here, all right? That negative 5, what that does is it makes it start going down instead of start by going up. Everything else is going to be the same. So I look and go, okay, the absolute value of negative 5 is 5, so the amplitude is 5. So I say 1, 2, 3, 4, that's negative 5. 1, 2, 3, 4, and this one right here is 5, okay? I know it has a period of 2 pi. Halfway between there is going to be pi. Halfway between there is going to be pi over 2. Halfway between there is going to be 3 pi over 2. Okay? And so I know this starts at the origin, it ends at the axis, halfway between it passes through the axis. Halfway between these first two, it normally hits its high point, but because a is negative, it's going to go down. And halfway between the second two, it normally hits its low point, but because a is negative, it's going to go up. And so this graph should look like this. Okay, again, definitely not perfect, but you can see generally what I'm talking about. And so if someone saw this graph, because of what they see here and here, they would know that the amplitude is 5. And also, because it's going down first, they would know that the a value has to be negative 5. And then because they see that after one complete cycle it gets here, they know the period is 2 pi. All right, hopefully that's making some sense. All right, so now let's change it up. We're going to change something else about it. What we're going to do is we're going to change the period. Okay, we know that every time I graph these, I say, okay, hey, this part right here is 2 pi. This part right here is 2 pi. And we're seeing that one complete cycle or one complete period happens between 0 and 2 pi. And always, in case you're not sure how I'm doing this, I always go, okay, whatever this number is at the end, I know that this one is half of that. So if it's 2 pi, then this one is pi. And then this one right here is going to be half of this value. So it's going to be pi over 2. And this one is a little bit tricky, but you've got to basically count your pi over 2's. So I got 1 pi over 2, 2 pi over 2's, which is pi, 3 pi over 2's. So that's what this one is right here, 3 pi over 2. And then this is 4 pi over 2, which is 2 pi. All right, so let's talk about what affects the period. We know that if we put a value out in front of the function, that affects the amplitude. But if we put a value in front of that x, that affects the period. This says y equals sine bx, meaning that that b is a constant right there multiplied onto the x. And here's the weird thing. To figure out the period, you actually have to take 2 pi and divide it by the b value. So this is something that you need to write down. Y equals sine bx and y equals cosine bx. The period, you find the period by taking 2 pi and dividing it by whatever that b value is. All right? And now what I'm going to do is I'm going to show you how I would graph these. Okay, we're going to start with a really easy one, like y equals 2 sine x. Okay, clearly the b value is 2, so therefore the period is equal to 2 pi over 2. The 2's cancel out, and I just get pi. Now, I'm not going to go and try to make this especially short to graph it. I'm just going to change kind of how I graph it. All right, so now, again, with sine, I know I start at the origin, and I know I end at the axis. I know halfway in between, I pass through the axis. Halfway between those first two, I hit my high point. Halfway between those second two, I hit my low point. Now, what I'm going to do different is I'm just going to do different on how I label it. This part right here is pi, because that's my period. So that means this part right here would have to be pi over 2. It's got to be half of it. This part right here has to be half of that, so that's pi over 4. And that would make this part right here 3 pi over 4. And again, you could look at it as I'm counting pi over 4's. 1 pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, and then 4 pi over 4's, which is pi. And then I graph it. Go up to that high point, pass down through the axis, hit the low point, and go back up. All right? And so that would be how I would graph y equals sine of 2x. First thing I have to do is think about how does that b value affect the period, and then I just graph it accordingly. All right, your turn. What I want you to do is I want you to graph both of these functions. y equals cosine 4x, and y equals sine 3x. All right, I'm guessing it probably takes you like a minute or two to do each one, so we'll pause the video for just a few minutes, and then we'll see how you did. Okay, all right, these are simple. Please keep them simple. The period is going to be equal to 2 pi over b, which in this case is 4. So that means the period is going to be pi over 2. You go, wow, that's a really short period. And that's true, but it's not going to radically change how I graph this. Okay, I'm going to still draw. I'm not going to draw the graph so skinny that it's hard to draw. I'm going to just say, well, okay, it ends right here, which happens to be pi over 2. I'm going to mark this middle point right here, which is going to be half of that, so that's pi over 4. The middle of those two is going to be pi over 8, and now I count my pi over 8s. I got 1 pi over 8, 2 pi over 8, 3 pi over 8s. So that's what goes right here, 3 pi over 8. And 4 pi over 8 would be pi over 2. All right, now this is cosine. Now I know cosine starts above the origin, but this does not have an a value besides that 1, that understood 1 that's there. And so the amplitude is just 1, okay? So it starts up here, passes through the axis here, hits its low point here, passes through the axis, and then hits its high point here. And so it should look like this. Something like that, okay? And because of how this is labeled and how this is labeled, anybody should be able to walk up to this and say, well, the amplitude is 1 and the period is pi over 2. And if you knew that the period was pi over 2, you should be able to work backwards to figure out what the b value would have to be. Okay? Now we'll do this one. This definitely was going to be a little bit of the tricky one. We got a 3 there for the b value. It doesn't make it harder. It just makes it a little bit different. So we got to think, well, the period is going to be 2 pi over 3. So that is the period, 2 pi over 3. So we go, well, I know sine is going to start here, and now it's going to end here at 2 pi over 3. So then we got to cut that in half, the halfway point. Well, half of 2 pi over 3 would just be pi over 3. Cut that in half, and that's going to be pi over 6. And then we just count pi over 6s. You got 1 pi over 6, 2 pi over 6, 3 pi over 6. Well, what is 3 pi over 6? That's a fraction that reduces to just pi over 2. Okay? And so this, whether you like it or not, this is going to be some good practice of fractions. Okay, they're always going to be basic fractions. They're never going to be too complicated, so it shouldn't be too bad. Now we know that sine always starts at the origin and it ends at the axis. Halfway between those, it passes through the axis. Halfway between the first two, it hits its high point, which in this case is at 1 because the amplitude is 1. Halfway between the second two, it hits its low point, which is going to be -1 because the amplitude is 1. And then the graph would look something like this. Up, down, and up. Okay. Oh, that's a terrible drawing. Does everybody see why? Because I made -1 go further down than +1 goes up. So that was bad. Once I looked at it, I thought, that looks wrong. Okay, so it should look more like, and I'm going to change the color so it doesn't blend into all the other things I have going on. Okay, goes up, comes down, hits here, goes back up. There we go. That's what it should look like. All right. So now what I'd like to do is I want you to be able to look at a picture of a graph and not only tell me what the amplitude is and what the period is, but I want you to be able to write the function, write the equation for that graph. I'm going to have you do some problems in the book that are on page 193. Okay. And first I'm going to start by doing one for you. But the directions say, just give me the period and give me the amplitude. But I don't want that. I want you to give me the graph. So here's the first one. Okay, you can see number 19. Even in the directions, it says, hey, give the amplitude and the period of each of the following graphs. That's not what I want you to do. I mean, you need to start with that. But what I want is I want you to write what the function would say. Okay, so let's look at this one. Clearly, the amplitude goes all the way up to 3. The wave goes all the way up to 3, and it goes all the way down to -3. So the amplitude is 3. Then what you have to do is you just got to follow along and see how long it takes to do one complete cycle. And you see that it does one complete cycle by the time it gets to pi. So therefore, the period is pi. So if I was doing the problem the way the book is asking, I'd say, well, this is easy. The amplitude is 3, and the period is pi. But what I want you to do is I want you to take this information and now write an equation. The first part is easy. Putting in the amplitude is easy. The second part, the period, is a little bit more difficult. You got to remember, okay, the period is always equal to 2 pi over the b value. So you could set that equal to pi, knowing that 2 pi over b results in just pi. And so then you can solve for b. 2 pi over b is equal to pi. We can get b by itself by multiplying both sides by b. These cancel out. You get 2 pi is equal to pi times b. And at this point, you can divide both sides by pi. And hopefully you already saw the answer at this point. But you go b is 2. I'm sorry if that's way down at the bottom of the screen. Okay, b is 2. So you know your a value is 3, and you know your b value is 2. So what would the equation look like? Well, it should look like this. Y equals, remember, what did we have? It was a sine function. Y equals 3 sine 2x. Okay? This 3 right here affected the amplitude. This 2 right here affected the period, and it resulted in this graph right here. All right. What I'm going to have you do right now is we're going to pause the video, and you're going to try the next 5 that are in the book. They're all on page 194. You're going to try numbers 20 through 24. What I want you to do is look at the pictures, and based on the pictures, establish what the amplitude and the period are, but then write the equation. Now, the good news is you don't have to draw anything, so these should go pretty quickly. I'm thinking probably a minute per problem or less. So in just a few minutes, 4 or 5 minutes, we'll start the video up and we'll go through and see how you did. All right. Now, hopefully you probably saw what I saw, and that the first 3 were really easy. The 4th one was a little bit odd, and the 5th one was just crazy, okay? But these aren't that bad. Okay, let's look at this first one. Clearly, we can see it's going all the way up to positive 4. It goes down to negative 4. It starts high. It looks like a valley, so this is clearly the cosine function, okay? And we can see that the period is 4 pi. So if the period is 4 pi, that means that 4 pi is equal to 2 pi over b, all right? And if you do your work and multiply both sides by b, okay, these cancel out, and then you divide both sides by 4 pi, look what happens. These cancel out. You get b is equal to 2 pi over 4 pi. Pi's cancel out, and you get 2 over 4, which is 1/2. So the b value is actually 1/2. When the b value is small, it increases the period, and when the b value is big, it decreases the period. All right? So this is real simple. The equation would be y equals 4 cosine 1/2 x. And that's what you should have. All right, let's look at the next one, number 21. Again, real simple. We can see right here the amplitude, the wave goes up to 2, goes down to negative 2. It starts at the origin. This is the sine wave. A little bit weird. The period is not 2 pi, but 2. Okay, and I'm curious if anybody was able to get this. So now we know the period, 2, is equal to 2 pi over b. Well, what would b have to be? Well, let's go ahead and multiply both sides by b, and then divide both sides by 2. These cancel out. You get that b is equal to 2 pi over 2, which is just pi. So see, if you make b any value of pi, then it's going to remove pi from your axis, and it's just going to be just your basic integers that you're used to. Okay? And we know the amplitude is 2. It's going up to 2. We know this is a sine wave, so we say y equals 2 sine pi x. Okay, that's what you should have. And one already started to get a little bit tricky. All right, number 22, this one, they had to throw a little bit of a curveball. Notice it starts down and goes up. But this is the cosine. It didn't start at the origin. It started off of the origin. This is a cosine wave. Okay, where is the period? It does 1 complete cycle after 2 pi. So the b value is just 1 because the period didn't change. What did change is the amplitude is 2, but it started by being down and then going up. And so if that's the case, then the a value must be negative. So this would be y equals negative 2 cosine x. The b value is just that understood 1 because the period is 2 pi. That's a pretty simple one. All right, then we get to number 23. Now, I know a lot of you might be like, well, wait, where's the rest of this graph? And they did. They cut it short and they, push it back over here. And so really you can ignore this part right here. And what's crazy is you have to think about this a little bit differently. This right here, from here to here, is 1/4 of the graph. Here's half of the graph. Here's 3/4 of the graph. And all of the graph would get me to somewhere right over here. So if this right here is half the graph, and it did it in pi over 2, then that means half the period is half of pi, which would mean that the period is pi. 1/4 of the period is 1/4 of pi, half the period is half of pi, 3/4 of the period is 3/4 of pi, so the period is pi, which would mean that pi is equal to 2 pi over b, and hopefully you can start to see at this point that therefore b must be 2, okay? Now, the amplitude is 3, all right? It went all the way up to 3, went all the way down to -3. It started up above the origin, so I would say this is the cosine wave, even though I don't see the whole thing. So I'd say y equals 3 cosine 2x. Love it if everybody got that. Okay, and then we get to 24. Now that you have a clue from 23, hopefully you can do 24 because it's crazy. Okay, again, what we need to think about is from here to here, we are seeing 1/4 of the period, 1/4 of one complete cycle. And so if 1/4 of it is equal to 3, so think about that. 1/4 of the period is equal to 3/4. Okay? I said 3 a second ago. I meant 3/4. So what you could do is you could multiply both sides by 4. These would cancel out. And you would get that the period is equal to, these would cancel out, 3. Okay? The period of this graph is 3. They give you these crazy, ugly numbers in all these weird spots. But the one thing you're supposed to be able to recognize, excuse me, is that this part right here represents 1/4 of the graph, and it is 3/4. So you can figure out from that that the period is 3. If anybody got this right, I am super impressed because this problem is weird. Okay? So if the period is 3, then I know that 3 is equal to 2 pi over b. I'm going to go ahead and multiply both sides by b. Okay, so that gives me 3b is equal to 2 pi, and then divide both sides by 3. So that tells me that the b value is 2 pi over 3. All right. Now, while that seems ugly, that's not hard for me to write in there. And I can see that the amplitude is 5. And this is the cosine function because it starts up above the origin. So what should I have written? I should have y equals 5 times cosine 2 pi over 3x. If anybody got this one right, you are a superstar. Okay. But this was supposed to be challenging, and that's where we're trying to get to. All right. Okay. So now what I'm going to have you do is I'm going to have you try to graph some of these on your own. Instead of looking at a picture and coming up with an equation, you're going to be given an equation and you got to give a picture. So I'm going to do one last example of that by putting both parts together, having a b value and an a value affect this graph. And I did fractions just to try to make it so I'm showing you one that could maybe be considered hard. All right. So if a is equal to -1/3, that means that my amplitude is 1/3. And the fact that it's negative means I'm going to start by going down instead of going up, okay? If my b value is 1/2, and I know that my period is equal to 2 pi over b, then that would mean that's going to be 4 pi. So my period got extended to 4 pi. All right, when I'm graphing this, I can draw my axis. Doesn't have to be perfect. I know that this whole thing ends right here at 4 pi. Halfway between those two is 2 pi, halfway between those two is pi, halfway between here, 3 pi, okay? I know that my amplitude is 1/3, so I'm going to make this easy on myself and say, okay, here's positive 1/3, and here's negative 1/3, okay? Now, if I graph this on a calculator, it would look pretty flat, but for the sake of making it relatively easy to draw, I'm extending it a little bit. You don't have to do it that high. You could have put it down here or whatever. It doesn't matter, okay? Now, remember, because this has a negative out in front, it's going to go down before it starts by going up. I know it still starts at the origin, passes through the axis, and ends at the axis. And then I'm saying, well, it hits its low point at the beginning and its high point at the end. And so it should look something like this. Oh, almost missed it. Okay. And from this, anybody who looked at this could see, well, I can tell that the amplitude is 1/3, and I can see that the period is 4 pi. And they would then be able to come up with this equation that I gave. All right? Okay, your turn now. What you're going to do is you are going to now work on page 195. And on page 195, there are 8 graphs that you are going to do. Okay? Page 195. What I want you to try to do is draw your own graphs for numbers 25 through 32. Okay? You can do it. Good luck. If you need a little bit of help, the answers are in the back of the book for the odd problems. All right, you guys have a great day.